Cloud. All right. Okay. Welcome to the system design session on Thursday. And today's topic is the where is the Discord? Okay, here. Today's topic is the web crawler with P2P zombie network. So basically, we control a lot of hosts, but I think we can start from the web crawler design first. I paste in the into the coder pad, and in case you don't know that, I will paste the URL into the Zoom chat and also the whiteboard. Okay, I hope that you guys can see that. Oh, where is Abhishek? Oh, he's back. All right. So at Euro, I would like call for a volunteer to try this design this time. Is any of you interested in this topic? Want to discuss?
I can. If no one else is doing, I can do it because I have to give some interviews next week, so it will.
Already, okay. Nice.
Good for me. Yeah. So. So what are we doing? What's the? Just hold on 1 second.
Can you see the code pad? I don't see a login.
Yeah, you can share your screen.
Yeah, so we are going to design a web crawler, right?
Yeah.
And okay. So
yeah.
Should I share the? Can we put the links here so that okay, it's already there, coded pad. So let me share my screen.
So because there are some, there could be some data in the real interview, we need to ask about how big the system is, such a question, because actually in today's interview debrief, there is a interviewer talk about this issue that he talking with one candidate, and the candidate didn't ask questions, which makes the interview very unhappy for this.
Oh,
but
we
need to skip this part. Have really
let's keep it moderate, like not going. But so we want so I understand what is a web crawler. I don't fully understand what is the meaning of P2P zombie network. I know peer-to-peer network, which is like not a centrally controlled network, but it is peer-to-peer managed. But what is the meaning of zombie word here?
Maybe we can do this way. We can say that they are with many workers, and it's not many workers, many unreliable workers, because previously we assume that we are control zombie network, that all the people, a lot of people's desktop of their computer is under control of us, but their computer is not reliable, so they can turn off their machine at any time. So yeah, this time we want to talk about more about the fault tolerant.
Okay, so we are saying that the system is like highly unreliable, like more unreliable than the usual systems. Is that what we are saying? That because it is managed by like people. Okay. So so let's go to the requirements. So we have already mentioned we want to design a web crawler and highly unreliable. And so what are the requirements around like complete? So how frequently does the new data, like do we have some fixed set of data that we want to crawl, or like
this system we may assume that the data is bigger than the wiki. So maybe this time we can assume that it's the whole internet. We are actually Google.
so we are designing a system for we are designing a web crawler for Google scale. Is
Yeah,
that
Google
what you're saying?
scale. Yeah.
And okay, so and so we have this much amount of data. So initially we don't have any data, right? And now, like, first we have to crawl from the scratch. So generally, like, we crawl from the scratch the web, and then
Maybe
when
some starting point. Like we may have some newspaper website. Maybe we have the wiki. We can start from there. We have we have the initial server website, and we start from there to go to different websites.
okay. So we start from a website, and then whatever are the links in that website, we keep on navigating to them, and like keep on exploring the links and creating a kind of a graph of like, and then we keep on traversing that graph, right, to
Yeah.
discover the entire web, right?
Yeah.
Okay. Okay. Uh, so it starts like this, and then uh, so basically what we can do here is so when we start, right, and then from that one website we discover 15 links. So those each links we can give it to some other machines, and then that machine can explore itself and its node, and then they can keep on dividing. Like that's how that's how one approach which comes to my mind to divide the work. Okay, so and then okay, so now, but like, what is the information we are storing? What is the metadata we are storing? Like when we are doing the crawl, do we just
maybe the URL and the index. So we want to search the let's see. Oh, what's the previous? Yeah, we can skip the indexing part. We just want to save the content. Yeah, we may index the content, but it can be a V2, and we can discuss later.
Yeah, indexing is separate. I'm just talking about crawl. So I mean, in crawl, like, are we crawling? So we have to, yeah, I mean, I think we have to keep the entire page content, right?
Yeah.
Because that's how we can search for the words in that page. Otherwise, so uh, basically, yeah, I think, yeah, basically, I think it's kind of stripped down page content without any formatting, images, etc. Right? It's like a very lightweight version of that page without any, just the text, like most of the text, so that we are not consuming a lot of space, right?
Yeah.
Okay, so this is what we have to crawl, and then we have to store it. So what kind of storage will we use to store this kind of information? So I'm thinking that we create like files, and we, do we point, so so and then do we have a mapping of URL is to file path? Do we do like that, or we store the but we have to search for that content, and that content should be searchable. So
yeah, I think in this case, the normalized URL will be the key, and the content of the stripped content of the page will be the value.
okay,
Basically,
so yeah, we are Okay, so it's a okay, yeah, let's keep it simple for now. That it's a key value store kind of database, right?
Yeah, that can be data storage. That can be a database. That can be a object storage or anything.
Yeah. Okay. Uh, Key value data. Okay.
So as we are downloading the file and the on the web server, there is a hierarchical structure. So why we are not considering the file storage?
In fact, we can. Yeah, this is why we were talking about this is data storage, and that can be anything, including the file system. Is this your question?
Yeah, my question is that why we are considering some sort of a object storage instead of file storage? Because
Yeah,
we need the output in a hierarchical format. So like level wise. So you know that on the web server, all these web pages are on the level wise underneath a directory, and then there is a directory, and there is a directory.
Sorry, why do we need to store this in hierarchy? Because don't we just need to know what is the page and what is the content of the page and the URL?
So what is the intent to download that?
So that we can index. So basically, we will have the index on that document, that what words are present in that page, and then we will have some ranking associated with that page, that how many other websites or other things refer to that page.
And
So
if we have to serve a cache content in that case, how will we search it if we don't preserve the path?
no, I mean, why would you need a path? Isn't the URL of that page enough for you? Like, uh, so I mean, so for example, let's say a website, it has Wikipedia, right? It has so many pages, but probably maybe few of the pages are most popular out of so many pages of that website. So and I am just yeah, so those will have their own ranking. Why do I need to know the hierarchy? Where does that page exist in that website? I can just refer to that page by its URL, right? Am I missing something?
Yeah, I'm thinking from the point of view where we have to clone the portal, and we have to serve it from there.
Oh, you are saying that if you have, okay, you are saying that you have to clone entire Wikipedia and then you have to, okay. No, yeah, I think that is not the requirement,
Okay.
right? We don't have to clone the entire, I mean, we don't have to eventually this web crawler, how it work, it will probably, I don't know, maybe yeah, I don't know how these web crawler actually work. It might be
yeah.
one of the ways.
I think in the real web crawler, we only index the content. So because the purpose of web crawler usually is to search. So when we download the page, we index the page and store it somewhere else, but then we discard the page itself.
Yeah.
Because I don't want to introduce some complexity here about indexing, so that's why we start from saving the content.
Okay.
Okay.
So this is okay. So simple. Yeah. So these are the requirements, right? We need to start crawling, and then we need to store this key value store of the data, right? Okay. Uh, okay. So now let's do some estimations on like how much machines, how much storage, and all like this to actually do this processing. So by Google scale, I don't know exactly what the Google scale is, but how
So,
much data do we have to store? Sorry, someone was saying
so
something.
one quick question, Abhishek. I read that I don't know. I mean, whether it's a central based on the centralized system, or I read the title that it should be P2P, right?
Yeah, P2P, right? Yeah.
I don't think this is necessary. We can have a lot of machines, a lot of workers, but we probably also need some centralized place to allocate work to those um, to those workers.
No,
So
that
we
is fine,
need,
but that we have to decide, I mean, how much percentage of dependency we want on that centralized system. If we are talking in terms of P2P, so I think, I mean, the estimate will be different.
Okay, I don't know how we're going to do it in a purely P2P way.
no, but if we are saying peer-to-peer, then there should not be any central thing, right? It should be peer-to-peer. Otherwise, it's some centrally controlled system if it's not peer-to-peer. So are we using peer-to-peer, or it's okay to have a centrally controlled network?
Because we need to have a place to store the data. So this is already a centralized design.
But no, why each node can store some data, right?
Yeah, then the fetch the data needs some way to get the data, because let's say this way, let's say we have the system design is done, it's working, and you put the data in distributed in different machines, and if we want to look up some page, how are we going to know that which machine we are going to go to?
Yeah. Okay, I got you. So see, there are two things here. So first thing I think you're saying is how do we get to that machine? But I think that is a separate problem. I think right now we are designing a web crawler, right? Whose responsibility is just to crawl the pages. So then this is another problem, that now you have crawled, now you have indexed your pages. How do you search, right? That is another problem. Then one more thing I'm saying is, and then which approach is easier? Generally, like I have felt that centrally controlled approaches are easier. Like you have one central network which is in charge. Peer-to-peer is harder. So again, for the ease, I think it's easier to have centrally built systems. So if we are okay, we can.
Yeah, I think we can. I would say let's start from the
Easy
easy
solution, right?
Yeah, easy one
Okay.
first.
Okay, so let's quickly do some estimation. So, so we need some. So we have like lots of data. Like I think lots and lots of data. So we need like thousands of nodes to store data, right? And then similarly, we need thousands of nodes to crawl, right? And yeah, I think yeah, and just I was just thinking about, are there any what happens if the page we crawled it got refreshed and all? How will we solve those problems? So the page we crawled, it got deleted or it no longer exists, and those kind of problems.
Yeah, we need to constantly refresh the data, refresh the page.
Data.
Yeah.
So I think that is one thing which we have to do, that how to refresh. Right. Okay. So okay, and I think it should be. I don't think. I mean, our system should be highly available. We need to keep on crawling. Consistency, I think it's fine. Yeah. So this system need not be highly consistent, right? Because worst case, the website no longer exists, because anyways we are storing the links to the pages, right? So when it might happen that when the user searches, that site no longer exists, but it's okay because if the site could have changed at any moment, right?
Yeah, that's right.
So, yeah.
This makes sense.
So okay, so now these are our estimations. Okay, so now we want to do some high level design. So let's go to the drawing.
Yeah, there's a trick that if you go to the this one can be expanded into a separate window. And I tried it in my iPad. It's working well.
Okay.
So this crawler is to crawl only Wikipedia or the entire internet?
Yeah, entire internet.
Okay.
Yeah, last time we find that if we crawl the Wikipedia, we don't need a lot of machine. Wikipedia actually is very small.
Yeah.
But
And it has only text.
still, I think it has I mean, maybe millions of, right?
It's only several giga, I think. How big is the wiki?
Number of pages in terms of, I mean, in terms of size, it could be, but in terms of number of pages, I think it's several millions.
Let me see. Article. Okay, 6 million.
Yeah.
6 million pages. Okay.
Yeah, it's wiki.
Okay.
So do we have to respect the web server here? I mean, what is that file name? The robo?
Robot. Yeah, let's ignore that. That's.
Oh, yeah. Okay, that's a good. So the files which are robot, those can't be crawled, right?
Those servers should not be crawled.
Crawled.
Yeah, that's server will say that don't do that for my.
Okay, so I think that's a good point.
And do we have to respect the server in terms of the request? I mean, if we will not control that, it could be possible that the server may have the rate limiter.
Oh, that makes sense. Yeah, not a real. I think this is not a very hard thing. We can. Yeah, I think we can respect that robot.txt file.
And what about the server load? Do we have to respect that? I mean, we should not actually make too many requests in a short span of time. We should actually delay the request.
That's a good question. Doesn't answer.
Yeah, it depends on like what the design is, right? So do you have some design in mind where we're constantly making a request to web pages so that we can update the content? Is that something you have in mind?
Yeah, I mean, if we have to respect that, then we have to consider some sort of a queue at our side. And one more thing we should consider in our design, that how many number of connection we can open with the server, or we have to respect and just keep only one connection with the server.
For one particular web server,
Yes.
website, web page.
Yeah.
Okay.
So Abhishek, in the requirement says that highly unreliable.
Highly?
Oh, that's the thing, because previously we say the P2P and we have zombie network. And now that I think that zombie network may be not very clear. So, but let's say that is we control previously thought we control a lot of people's computers. Then those computers will be not very reliable, so they can turn it off at any time, and even the data may not be reliable because they can.
So highly reliable nodes are the nodes which we are crawling, or are our nodes? Like, are they the destination machines which we are crawling, those web pages, or is it our infrastructure is highly unreliable?
I think our workers should be considered as not reliable.
Okay.
And also the website, I think by nature, websites are also not reliable because they can,
If website is not available or unreliable, then I mean it's not a problem, because I mean for that we have to see something that.
So are we thinking to, I mean, crowd crawl?
Oh, what do you mean?
I mean that, I mean, use the PC belongs to someone else.
Yeah, that's a zombie network.
So that means the crowd, we are using the crowd, other PCs to actually crawl for us and pass the data. Okay.
Well, are we designing something like that?
Yeah, that's workers.
That was the initial plan. Okay.
Yeah, just worker, and the worker is basically malware installed in other people's computer.
Yeah,
Yeah.
just like people use the other someone PCs to mine the bitcoins.
Yeah, or like torrents or something, right? Torrents are
Yeah,
also.
exactly. Yeah.
Yeah. Okay. Okay. So basically, okay. So let's say we have a master node, right? Uh, which will do the orchestration of like who to send request, and then so basically we will start with some one web page, right? And we will discover few links in it, and then for each of the link we will delegate it to one of the worker nodes. So master will be talking to worker nodes. There are multiple worker nodes. uh, these worker nodes will be crawling and returning the web pages, web content, uh, and we need to. So these worker nodes, which are the crowdsourced, they won't be storing the data. They will be returning the data, and it will be stored with us, right?
Yeah, because we have them so many workers. I feel like we need to delegate some of the parting work to those workers.
But are these workers doing the processing for us, or are they also doing the data storage for us?
That's not store the data there because that will be very hard. But let's say that we can send a request to one of the worker, and that worker will, I would say that they will give us the content of the page first, and also parse it for us to say how many new links in this page, so that we can put this new page in the queue and do the remaining work. What do you think?
No, but shouldn't the worker do the work and return the pages? Like, why is so all okay? All if uh no, okay, but if the web pages are a lot, yeah, yeah, okay.
And
So it's a never-ending like graph, right?
Yeah,
For that
so
link, it will discover a lot of pages. So yeah, so it will return it to the master.
yeah, in this case, we need a queue to insert the subpage into the queue that we are going to do this work. We are going to scroll these pages in the next round, not really the next round, but in the later time. So basically, we have let's draw this. We have, and I'll try my iPad. So we have the page. Oh, so we have a
So
page here, and
why do we want to actually return the URL to the master? When the worker download a page and parse it and get the URL, so why don't we give this responsibility to the same worker that download those pages as well? And it just verify with the master that whether this page is already downloaded somewhere else or not.
I think so. I think we can
But yeah,
delegate
I
a bit
mean,
more
the
work.
point is like it has to return some information to the master, because like for a link, there can be the graph of downloading the page will never finish, right? Because if a worker is given one particular page to crawl, right, it will have more links, and then that will have more links. So eventually, the worker has to tell master, right, that I'm doing this much work, but this much work is still left.
Yeah, just like this is my web page.
Yeah.
Web page, and the web page have multiple link to another web page, and there could be some cycle here that can point into the previous one. So my thinking is that we can first put this into the queue, and then in the next layer we put this into the queue, we put this into this queue, we put in the queue, and then we do all the remaining in this more like a BFI search style traversal thing. So we cannot, we may go deep a little bit, but we cannot go too deep, because otherwise it will be running forever and it will never return the value. And also another risk that another worker may pick up the same thing.
Yeah, and also the worker
That-
can die also, and master would not know like how much links that worker has done, or how much has to be done. Like more work has to be done if the
Yeah,
worker dies.
So that's why I'm saying that, I mean, worker will keep the responsibility, but it will notify back to the master that, okay, here are the links and I will work on those.
So there are two, I see there are two different kind of jobs. One is like exploration kind of job. Another is downloading the content of those pages. No, right. No, I think, but when you're exploring, you can download the content also, because to explore, you would have to download that page. So, oh, okay. So, can we do something like this, that basically first we have to define like something like what is the capacity of each of the nodes, how much it can process. So when it will start exploring a link, right, it will start exploring the pages, and once it sees that it has a lot of links, it will talk back to the master that uh, that now someone else should be dividing the work with me, and they should be picking up the pages from here. And so that's how.
I think we can do that. So maybe we can give us an example how I'm going to do that. I can clear my section. Can you draw it here?
Okay, I okay. So what I'm saying is that okay, so mm, uh, just 1 second. Okay, so we have these master and we have these multiple machines, right? So let's say so this worker is given one link, right? So then this worker will start exploring the link, and it will be returning the key and the content to the master, whatever it has crawled. We will see whether it will return to the master or whether it will itself store it at some place that we can see. But let's say it is returning to the master, right? And then, so now worker will start exploring the graph of that page, right? At one point, like the graph will become too big for this worker to explore itself. So then it will say that, like, from this point, whatever is the exploration, it will return back to the master that like give it to another node. I'm already busy with exploring these nodes and this work.
Yeah, it seems that the worker will handle, let's say that we can handle hundreds of new URLs. So we have one page, and that page can generate 10 URL. And we, for each of URL, we also generate a couple of new URLs. And when we reach the 100, we want this to process forever. We just return those 100 URL, maybe less, to the master. Is that what they're saying? Okay.
Yeah. No. Okay. Yeah. That is one thing. Another thing I'm saying. Yeah. So another point is that the worker needs to know whether everything beyond this page has been already crawled by someone else or not, right?
Yeah.
Probably someone else has already crawled it. So it should have that access to the central information that what web pages and beyond those web pages have been crawled. So
Yeah.
we need, huh?
I think if we have many workers, we may have some duplication. It's acceptable.
No, but not about just duplication. Like how will we know when to end, right? Otherwise, this graph will never end. Like it will keep on like there might be a cycle or something, and it might keep on running. So at
Yeah.
some point, it should know, right, that it has crawled this page. I mean, I think otherwise it will be very expensive because a lot of pages will be pointing to like similar pages, and we don't need to do the work again and again to crawl those pages.
Yeah, maybe we can. Yeah, I think that in this case, we need to design a queue that we can insert new URLs to the queue, and that queue will remove any further duplication because of the cycle. But we do not want to remove the duplication if we have the some URL get downloaded, parsed, but that's a long time ago. So we need some way to refresh it.
Yeah. Okay. Yeah. I mean, yeah. So that, yeah, we also need to refresh. Yeah. Refreshing is also one part. But okay, let's talk about like this high level design. So we have these worker nodes, which will be exploring some part of those web pages, and it will be returning it to the master node. And then somewhere we will be storing all this information key value pair, right?
Yeah.
So this, yeah, I mean, we have some databases where we are storing this information, a database or whatever, or data store where we are storing this key value data. So okay, so now the problem is that we said that these. So first is that how will we manage the configuration and this information, that which worker node is storing what information, and then and then the other problems are like, what if these worker node die? Who will take the responsibility? How will we manage the responsibility handover, right? So uh, so for this configuration kind of information, that uh, who is going to crawl starting from which website, we can use some config management services, right? Like Zookeeper or something, which will have the information which node is storing the data, right? So this metadata, for this metadata, we will have the Zookeeper that worker one will be like storing this web link, then worker two, right? And so then the master like knows that which worker is doing what.
I think Abhishek, let's actually finish the end-to-end flow for, let's say, um, one master is able to serve that. And then we can think about the scale from there.
So what can you elaborate? Like, what do you mean? Like,
So
what
like
are the? Mhm.
how the seed URL will come, and then these nodes will communicate with that service to get that what URL is next for me, and then they download it, and how they will return back to the some centralized system which will actually accept the content and update these metadata and the content. And as Aaron mentioned that, I mean, it could be possible as these nodes are not reliable. So we cannot actually remove that URL. Let's say if a node comes and asks that, okay, what next for me? And the centralized system hand over the URL to that node. But we know that that node is not reliable, right? So we cannot actually remove that from our queue until we get the confirmation or until we get the data for that URL. So at the same time, now second node comes. So we will hand over the same URL to the second node.
The second node, yeah.
Until one of these URL return that, okay, I downloaded the page for the here and here's the content, then at that time we will remove it from the queue. And other node who actually already working on that, and when they will hand over the data, we will discard that data because we already received that data from someone else.
That makes sense. Yeah, here with this queue, the item simply the set of the workers. So one seed URL can be ready. It can be in the set of ready and can be instead of the in the state of running, and it may fail. Yeah. Sounds like this is a typical scheduling design.
Yeah. Okay. Okay. So I have to leave in like 5 minutes. So probably someone else has to take over it. But I think, and probably I'll wrap up from here. And I think, yeah. So we can discuss about this queue design, what you have in approach, and take that further.
Yeah, sure. Oh, you're leaving now?
Yeah.
Okay.
Yeah.
Okay. Okay. Thank you. We will see you next time. And yeah, we need another volunteer to continue this work.
Could you share that? I mean, CoderPad, I can.
Yeah, sure. Let me find that. This in the Discord, and I think you guys may not copy link.
Could you please post it here?
I posted in the chat.
Discord. Okay, give me 5 minutes.
Yeah, it's in both places.
Okay, give me a minute.
Mm-hmm.
Let me put my pen. Do I need to share my screen or?
Yeah, you can share your screen, and you can actually share only one of your window.
Okay.
The trick here is that if you open the CoderPad, you can open a drawing mode in a separate tab, and you can share that tab only. And you said that you have a pen?
Oh, yeah.
Okay, you're going to use it in the tablet?
Yes.
Nice.
I'm going to use it on my Surface. So where's the system design window? Just trying to find show.
Yeah, actually, then you can draw there, and I can share my screen because I can see the content in real time.
Okay.
Okay, let me share it. Share screen. Okay, here. There is an icon here that can change the position, and there are the option that you can change the color. there's a pen.
So what I'm thinking here that, I mean, let's say, so we have some sort of a header,
Okay. Oh,
right?
this is really big.
It's
Okay.
big.
Yeah.
Then, yeah, and then let's say somewhere outside our boundaries, these are the node 1, node 2, right? And they all talk with this seeder service, and the seeder will get the initial seed URL or the URL, whatever we want to process or download. And when they are done, so there will be a service, something in our premise. Let's say outside, this is also our premise, and we have a something here which will take let's say content collector. May not be the good name, but yeah.
Okay.
So they will download and hand over to this service. Now this guy will actually check in the database whether this particular URL, whatever they are downloaded. So here we will collect the content, and it will check that whether that particular page is already downloaded or not. If it's downloaded, so we will discard it. If it's not downloaded, then we will process that.
You're going to index the content?
Now process to extract the URL.
Okay.
Right? And at the same time, this guy will save the content in the database and update the metadata. And now this guy will check that, let's say, there is another service to duplicate check. After extracting the URL, this guy will check and pass here, verify that is there any URL which we already downloaded.
Okay.
So it's some sort of a filter, right?
So this part, the data in the lower position, that is your queue. Oh, this is something different.
Which one?
The lower one. Let me.
That one?
Yeah, this one.
This is my database.
Okay.
Metadata.
Metadata. Okay.
Yeah. And after this guy verified that, then whatever URL will left, it will go and push to the seeder.
Okay. Okay, then this is the loop. So we have the workers who download the page and process that.
So the end-to-end flow will be like that. Initially, we will push some URL through some database here. We will push some initial seed URL to the seeder. Seeder will, and all these nodes, somehow magically we will have our client running on these, our web crawler running on these nodes. And that web crawler will talk to the seeder to get the URL. And the seeder will hand over the URL to whoever come first. It will hand over, hang on, one more thing. Yeah, so as soon as there is one more actually link missing. When we actually save this URL here, so the contract service should notify back to the seeder for that URL downloaded.
The,
And the purpose of, okay, let me explain that. I mean, what I'm thinking here.
okay.
So initially we will have some seed URL, and these web crawler node will request for the URL, and initially it will hand over the first URL to all the nodes, because we don't know which node will download it. It could be possible that node may accept the URL, and after that that node died. So we will know after hand over the URL, we will not remove the URL from the queue. This node now, after these node download the content and hand over to the content collector. Now content collector will verify that whether we already downloaded the content for this URL or not. If we downloaded it, it will discard it and will not do anything for that. If it's not downloaded, then it will push the content here in this database and push the metadata here and notify to the seeder that this particular URL has been downloaded. So remove it from the queue.
Okay.
And now collector will pass this content to the next service process extractor, which will extract all the URL within that page. And then after extracting those page, it will hand over to this next service that is a duplicate check. So let's say within that page there are 5 URL total, and out of these 5 we already downloaded 2. So it will remove those 2 URL and pass these 3 URLs back to the seeder.
Okay. Let me ask this question. So the seeder have the initial URL and pass into some workers. And what is this thing here? Wonder that what is this
URL downloaded.
URL? Okay, you see that this URL is finished.
Yeah, so remove it from the queue.
Okay, I see.
Yeah.
I see. So how we can have the URL refreshed? So each time we may have some roughly accurate timestamp for each URL, so that for the content, let's say this content is downloaded last time. So maybe some URL is updated last month, so we want to download it again.
Yeah, so we can have a scheduler service. And here in our metadata, we can keep the timestamp with the download time with the URL. And this scheduler will fetch the URL from here, whatever URL we need to refresh, and then it will push back to the seeder.
Okay. I see.
It's a very bad design, I know. I mean, drawing.
Yeah, the drawing. Okay, I think we need to accept this. And audio tone is pretty big. Yeah, so because I was thinking something similar, I want to have a service, but this service is basically a queue service. Let me show you. Oh, okay. I think I cannot. I need to use a 100% somewhere in the corner here. Let me draw. Okay. There's no way to reset it. So yeah, I would like to have a queue that there are many items here, and each item may have what kind of thing we want to record here. So basically, we want to define the feature that we can insert a URL,
Okay.
and we may have the timestamp here. And it will say that we are going to get the content of this URL, and then when we this URL will be sent to the downloader, and we download this content so we can have update the URL and with the content. So that means that it's refreshed. And when we update content, we also insert a bunch of new items using the first insert function, and with the timestamp. And it is possible that
So you're saying that, I mean, when you will push to the queue, so in the queue you will push that the URL and the timestamp?
Yeah. So I want to create a loop that each time we will try to insert a new URL parsed from the current content, and this insert may fail, which means that there is already an existing URL which is updated recently only. So if that URL is updated a long time ago, the insert is still a successful operation, and there could be a time that this is inserted recently. So
So what is the benefit? I mean, you are getting here having the timestamp with the URL?
yeah, I want to make this design simple so that we have so many things here. Then I was thinking that maybe we can have a very simple loop. We're using some queue here. We get the data. We get the data from the queue,
Okay.
assigned to a worker, and the worker will get the new URL back to the queue again, and over and over. So it's a very simple loop.
So you are saying that the URL will always will forever stay in the queue? You will just change the timestamp?
Yeah, the URL will be there forever.
So consider that, I mean, billions of pages. So that means billions of URL, billions of entries will be in the queue.
Yeah. That's why the data, the DB will be big. So because I think I remember read the paper about the big table. The original use case is to handle this scenario that each entry have the state that this is going to be updated, or maybe that is the URL is already updated recently. I can't remember what's the different state. But you can always get the next available, a bunch of next available URLs from this queue service.
One drawback I do see here is that when you actually when we go with this design,
Mm.
and let's say somehow we want to change our refresh time interval.
Yeah.
So that will be difficult because now we have to update all most of the entries in the queue. But
Oh.
with the scheduler design,
Mm.
we just need to worry about the scheduler.
I am confused. Can I say that again? What?
So so if we go with that queue based design where we keep the URL with timestamp, and
Uh-huh.
when we fetch that, we update the timestamp and push back the URL again in the queue, right?
Mm.
So now let's say some due to some circumstances we have to now change the time, change the refresh interval.
Okay.
So now whatever entry we have now in the queue, either we will have to update those entries.
So it. Oh, my head is stop working. I don't know. Yeah, let me think about these scenarios. I don't
Yeah,
know what answer.
let's say initially we decide that okay, we will refresh it after a month, right?
Mm.
And we crawl and update the entries in the queue
Mm.
with that after a month. And now we decide that okay, now we instead of after a month, we will either refresh it in 15 days, or let's say take an example, we will refresh after 6 months, not in a month.
Mm.
So now we will have to update all the entries in our queue.
Yeah, then in this scenario, we need to start from the oldest URL in this queue.
No, but we want to refresh after 6 months. So until unless we modify the entries,
Mm.
we
Or maybe
cannot
we can,
stop.
yeah, maybe we can, instead of having the current timestamp, we may have the expire time stamp.
Mm-hmm.
So then the next time when we change the interval, it doesn't matter because interval is used only when we update update the content.
Okay.
Yeah, thinking that, yeah, the table can be big. I think this is true. I think this is unavoidable.
Mm-hmm.
I think in other scenario, if we want to refresh the URLs, then we need to remember those, and that can be a lot. So let's say that Wikipedia have 6 million, and if we want to double, we can do 10 times bigger, 60
Right.
million, 600 million. Each URL can be several. That's really a lot, but yeah, still one machine cannot handle it properly.
Oh,
Okay.
definitely not one machine. So definitely, I mean, we will shard it
Mm.
uh, based on domain.
Yeah, maybe the URL itself in the reverse order, like we do the com
Mm-hmm.
first, and then we have some company first, company then, and some www, some such a thing.
Yeah, we did not talk about the scale. So definitely shard, even this seeder
Mm.
service, this will be distributed, and this will be again based on the shard,
Mm.
the domain. So that I mean, and we can assume that these nodes, so we should actually these should be close to the infrastructure, like where is the in whatever zone that seeder service is available, whatever zone this the content collector service is running.
Mm. Yeah. Okay. I think I'm not sure. I'm really tired now. I'm not sure about other guys. Maybe the remaining part we can talk next time.
Yeah, sure.
Okay. Oh, we have just a few. We have 2 guys left here, and let me put it a note in Discord. Next time we will continue to discuss web crawler and focus mainly on the queue. Can we see that?
Yeah.
Oh, what do we say that? Queue or refresh? Yeah, refresh. What do you think?
Yes.
Okay. And we will focus it. Or maybe we can add indexing. Sounds good?
Yeah. So, I mean, in terms of that P2P side, so you are expecting to just that P2P side or will only download the content. That's it.
Do you want to talk more? We can talk about next time if you have something to talk.
No, I don't. But I mean, it's something interesting that I mean, something new things we can think about that. Let's use the someone else machine to do the full job for us.
Yeah, I feel like that can be very hard to explain actually.
Yeah, I agree. I mean, it could be, but I don't know. I mean, whether we can come up with a concrete solution or not with that.
Yeah, maybe we can talk next time. If we have some time, we can talk about a little bit about the P2P, how to make it help our solution.
Yep.
Okay.
Hey, thank you.
Okay, thank you guys for coming for this session. See you next time at the same time.
Thanks.
Bye.
Bye.